Bismillahirrahmanirrahim. This video is from chapter number 8, and here we'll be solving example 8.10. Before we begin, let's just recall the time concept that we had discussed. A couple of videos I had discussed this. This is the 0 point, 0 axis, and the left of 0 is, we call it t less than 0, and the right of 0 is called t greater than 0. Now, around t is equal to 0, there are two more points. One is t 0 negative. So this point is t 0 negative, just slightly short of t is equal to 0. And then the next point is t 0 positive, which is just a little ahead of t is equal to 0. Now, why do we discuss these? The concept is that in case of an inductor, whatever is the current at this point here, that is at t0 negative, the same current will be at t0 positive, although the input current might have changed. And in case of a capacitor, the voltage, whatever was the voltage here, same voltage will remain here. So the concept is that the inductor current does not change instantaneously, and the capacitor voltage does not change instantaneously. For that, we'll use this portion. Then after that starts the transient period. So whatever voltage or current we have applied, it starts from the, let's say it was 0 initially, then it starts increasing. And for, as we know, up to 5 tau is the transient period. And after that, it becomes a steady state. And that period we call as T steady state or T infinity. So I have divided this into 4 steps. The first step, we calculate the values at t0 minus, then we calculate the values at t0 plus, then we calculate the values for the transient period, and then we calculate the values for infinity, t is equal to infinity. Now in case of a second degree equation, the complete solution consists of the transient response, which is also called natural response, and the steady state response, which is the t infinity, at t infinity. So the total current it can be written as I1t plus ISST. Sorry, ITT, transient t, also called INT, and I steady state t. Now this is the question that we have to solve. Find V0t for t greater than 0 in this circuit. So this is V0. So we have to find V0t. That is the question in mind. And what is V0t? From here you can see that V0t is 1, the resistance multiplied by current. And how much is the current? I1 is entering from the top and I2 is leaving there. So they are in opposite direction. So we'll write I1 minus I2, assuming I1 is superior. So I1 minus I2 multiplied by the resistance is V0t. That means to solve V0t, we have to actually solve I1t and I2t. Okay, so let's start. The first step is that we are at t0 negative here. So for t less than 0 or t equal to 0 negative, we have to find the initial conditions, that is I0 negative and or V0 negative. Now in this case there is no capacitor, therefore we won't find the Vc, but we'll just find the inductor current and voltage. Now first of all, the input value is 7 ut. Now I hope you know the meaning of ut. Ut is 0 for less than 0 and 1 for greater than 0. For t less than 0, ut will be 0. So 7 into 0 is 0. That means this source will be 0. So let's draw this circuit now. with the source 0. So this is the circuit at t less than 0. And now since there is no source, therefore the current flow will be 0. Both the current will be 0, I1 and I2 0. So we'll write it like this, that I1 0 negative is equal to 0 and I2 0 negative is also equal to 0. Okay, now we'll use this later on, but let's just find that for t greater than 0, that is at this point here, we need to find dv dt 0 plus or di dt 0 plus. In this case, we'll only find di dt 0 plus because we have inductors in both the cases. Now to find this, we also need to find I0t or IL dt, and if there was a capacitor, then we should have found dct. Okay, and we'll use the rule that the inductor current does not change instantaneously. That means for t greater than 0, first of all, the circuit 7ut will become 1, so 7 into 1 is 7. So the circuit will now look like this, 7, and all the other parameters remain same, just marking here. Voltage we calling this VL1, this calling VL2, this was already given. Okay, so due to continuity of inductor, that is inductor current does not change instantaneously, I10 plus, that is the current at here, will be equal to I10 minus, and I10 minus is 0, therefore I10 plus will also be 0. And similarly for I20 plus, same logic. And what will be V0 plus? Again, we just use the formula that R into I1 minus I2. Now both of these are 0, therefore V0 plus will also be 0. Next step is to apply KVL to find VL1. So from here, minus 7, 3 into I1 plus, then VL1, and then VL0. Now we will put the value of I10, which is 0, we'll put the value of V0, which is 0, to find VL1. So arranging VL1 is now 7 volt. This one 0, this one. So VL1 we have found. Now we'll need to find VL2. Now VL2, look from here, is the same as V0 because they are in parallel. Therefore, since V0 is 0, therefore VL2 will also be 0. So VL2 is equal to V0 is equal to. Okay, so these 5 parameters we have found for 0 plus. And now we'll find the derivative terms associated with the inductor. We know the inductor voltage V is given by L di dt. From here, di dt can be written as VL1 divided by L1, talking of this one. And now putting in the value V at t is equal to 0, these all will be associated with 0 plus. So now VL1 0 plus is 7 volt, L1 is half, so di 0 plus dt is 14 volt. And VL2 is similarly L di 2 by dt, from here L di by dt 0 plus is VL over L2. Now this is 0, therefore the whole thing will be 0. Okay, and now we come into the transient period. We obtain the transient response for t greater than 0 by turning off the source. So we have to turn off the source to create an imbalance, to create a transient. This is as if somebody is standing on a chair and you pull the chair, so he will go into crumbling or he will become in the transient state. So we put this as 0. Now this is the circuit that we have. We'll solve this. During the transient period, the inductor will behave as inductor. This is a very funny statement that I have made, but Just keep in mind, we have learned earlier that inductors become short circuit for DC. But in this case, it will not become short circuit because we are in transient. So transient is kind of a AC. So it will not behave as short circuit, so it will remain in the circuit as it is. And now if you apply KVL in the left mesh, so 3I of di dt, and this one is, we have already learned, 1 I1 minus I2. Rearranging, we get this equation. And similarly, for mesh 2 or the right mesh, now it will be I2 minus I1 and 1 over 5 di2 dt. So from here, this is our second equation. So we have these two equations. Now what we need to do is get the value of I2 from upper equation. From here we get I2 and put this value of I2 in the second equation here and here. So this is, we replaced I2 here, and in this case d of I2, and by solving here, I hope you can do the differentiation. It will be 4 di dt, and this is now double differentiation, so it will be d square over dt square, and this is minus I. Rearranging, get in this shape. Further simplifying, we get these values. That is multiplying by 10 actually. Okay, now instead of writing d over dt or d square over dt square, we take a simplified approach. We replace them by s. We obtain characteristic equation by replacing the first derivative by s and the second derivative by s square. So this we replace by s square, this we replace by s. So our equation will be s square I1, 13s I1 and 30 I1. So taking I1 common and taking it out to the right hand side equal to 0. Our equation left is s square plus 13s plus 30. This is known as the characteristics equation. From this equation, we factorize it and we get these two values, s is equal to 3 and s plus 3 multiplied by s plus 10. Now we put these equals to 0. So like here, s plus 3 0, that means s1 is minus 3. Similarly, this one equal to 0, that means the second root, we're calling it s2, is minus 10. So the two roots are here. Now we have learned that the roots of the characteristics equation, if they are real and negative, then the response will be overdamped. And for overdamped case, we will use this formula. So this is what we are going to use here. So we now can get the natural response, which is this one, by writing from the transient of the natural response, I1 natural is A times, instead of A1, A2, we are just writing A and B. Doesn't make any difference. And S1 we are replacing by minus 3, and S2 we are replacing by minus 10 from here. So this is our transient equation or the natural equation. We still need to find the unknown constants A and B. Okay. Next we'll calculate the final value, or we are at infinity. Our t is equal to infinity. What will happen to this circuit? If it is infinity, that means it is connected for a long time. So the inductor will now behave as a short circuit. Our circuit will be like this: inductor shorted, inductor. Now here, short circuit is in parallel with the resistance, so this will all be short circuit. Actually, you can also think of this, that 1 ohm multiplied by 0 ohm, or 1 ohm in parallel with 0 ohm. So the whole result will be 0 ohm. So our circuit will become like this. And from here we can calculate I1, which we'll call I1 infinity, which will be voltage divided by resistance. So I1 steady state or I1 infinity will be voltage divided by resistance 7/3 ampere. So this steady state we have found, and we have learned that the complete response will be the summation of the two, steady state and the natural or the transient current. So this we can also write steady state first and then the transient next. And these are the two values that we have calculated. So our IT will now be, we are writing this ISS, and this is I1N. This is our complete response. Still we need to find A and B. Now to find this, we have to use the initial values that we have. And the technique is that we put t is equal to 0 in this. So at t is equal to 0, this will become the equation. E raised to the power 0 is 1, e raised to the power 0 is 1. This is one equation. But we have two variables, a and b, so we need another equation. So what we do is we differentiate this to get the second equation. And these values we have already calculated, which we will use in the differentiation. So the taking derivative of this di 0 dt, and this constant will become 0. From here we'll get negative 3a e raised to the power minus 3t, and negative 10b e raised to the power minus. And now if you put t is equal to 0, then this became di dt 0, this will become 0, this will become 0, and di dt 0 is 14 volt per second. 14 minus 3 and minus 10b. So this is our second equation. This is first equation, second equation. Using these two, we can find the value of A and B. Okay, so solving, I hope you can find. One technique would be that you multiply this one by 10, 10b, and add. So 10b gets cancelled. Find value of A from solving, and then putting value of A, you can find B. So just try it. You will get answer A is equal to negative 4/3 and B is equal to negative 1. So our equation with these values put in, this was the equation. And here, so we just put the value of A and put the value of B. So this is our final equation number 1, I1T. Now we need to find I2T. I2T, again we'll use the first loop because this also has I2 in it. So KVL in left loop, done this, simplifying, identifying I2 like this. And now substituting for I1. Here we substitute for I1. This is our I1. And here also we substitute I1, get I2. So 4 I1, this value, and half di, this is also the I1. And solving, this remains simple multiplication. Here you can, I hope you can solve or take the differentiation of this. This will be 0, this will be minus 3 e raised to the power minus t, so it will become plus, and 3 cancel, it will be 4/2 will be. So I hope you can get this. Rearranging the terms, this is our I2. So I1T we have found in terms of all the values, and I2T also we have found in terms of all the values. So now we can easily find V0T, which is 1 multiplied by I1t minus I2t. These are the two values that we have found. Plugging in the value of I1 and I2 and solving, simplifying, further simplifying. So this is the final answer. I hope you have been able to follow this. Please let me know through your comments. Thank you.